Okay, so we're going to talk about prime and composite numbers. Prime number, composite number. Does anybody remember? Because this flashes back like to kindergarten. I mean, these are early school skills that really apply big time when we're talking about anything having to do with fractions and multiples and factors. The definition of a prime number.
Like, does it mean that if you multiply a certain number by a certain number, it's only...
You're in the right neighborhood at the wrong house.
Oh.
You're thinking about the right stuff, but you're not exactly where we need to be at. By the way, if you're going to answer, you got to use teacher voice so that millions of people on YouTube can hear you. Yes?
A prime number is a number that you can only get with multiplication by multiplying that number by 1.
Yes, except for I'm going to simplify it just a little bit. A prime number is a number whose factors are 1 and itself. Which means you get a prime number by multiplying 1 times that number. And those are the only factors it has. Let's start with 2. Is 2 a prime number?
Yeah.
Yes, no, maybe. People are literally doing this because they don't know.
No.
So think about it. What numbers can you multiply together to make the number 2?
1.
And 1 times 1 is 1.
2.
1 times 2. That we literally don't have any, I mean, counting, we don't have any other numbers to work with. 2 is prime because it's the second lowest number. So there's not another number to work with. What about 3?
No.
Yes or no? Prime or not? 3. Guess. Yes. Good guess. 1 times 3 equals 3. Is there any other multiplication we can set up to equal 3?
No.
No. 4. Prime or not prime?
Not prime.
Why?
Because you can do 2 times 2 equals 4.
There you go. Because something else we can multiply. 5.
Yes.
Yes, prime. 1 times 5 equals 5 is the only math problem we can set up. 6. No. Why?
Because you can do 3 times 2 and it'll equal 6.
3 times 2. So it's literally anything other than 1 in itself, right? 7? Say yes or no.
Yes.
Yes. 8?
No.
9?
Yes.
No.
No. Now what you're noticing is the pattern of odd numbers, right?
Oh.
Why is 2 the only prime number that's even? This is a tougher one than it sounds like.
Because it's the lowest number. Well, why the lowest number?
It's one of the lowest numbers as a starting point. But why couldn't 4 be prime? Why is it literally impossible?
Because you can't do anything else except 1 times 2 to get to it.
You're warm. What's the definition of an even number?
Anything that can be divided in half.
If you can divide it in half, you divide it by 2, right? That means 2 has to be one of its factors. 3 times 3 is 9. So it can't be a prime. It has to be 1 and itself. What about 10?
No.
2 times 5. 11?
Yes.
Yeah. 12?
No.
13?
Yes.
Could we literally keep going like this forever?
Yes.
Yeah, we definitely could. I mean, numbers are infinite, so we could actually and literally go forever. So, composite numbers are everything else. When I think of composite numbers, I always go back to construction because I'm terrible at construction, and my brother's a carpenter, so he talks about this stuff all the time, and I only halfway understand it. If I have a composite board is a board made up of a whole bunch of different kinds of recycled plastic. It's like got all kinds of pieces to it, but it's all put together to make one thing. A composite number has a whole bunch of different multiples or a whole bunch of different factors that can be multiplied together to equal that number. Like 4 is a really small number, right? But you still got 2 times 2. And 9, you've got 3 times 3. What if you get up to like 16? 16's got all kinds of factors, right? 2 times 8. 4 times 4. So by the time you get up into like 24, 24's got 8 or 10 different numbers that are factors, right? So a composite number has more factors than one in itself. So here's how this works. Weird numbers that fit a very specific idea, right? A very specific set of circumstances make something a prime number. Correct?
Yep.
All the other numbers. Anything that has more than 2 factors. Good to go?
Yeah.